This will end up being the first of a few videos all about percent of change. There's so many different ways you could do these problems. But let's just talk about kind of the way we're going to do this, the way the book likes today, actually works out. So this will be in red. You don't have to write any of this. It's just kind of the intro idea. You know that you have a test, and you got a test, and who knows how you scored on it. But normally when we think of scoring, this is like the total points or whatever, and most things we experience out of 100 because that's nice for dealing with a percent. Well, for every 10 points I increase on a test that's worth 100 points, I know that that's going to be like a 10% increase. So if I get 10 out of 100, that's only going to give me a 10% total. But then if I jumped up another 10, I'd be gaining another 10% there. So I feel like it just kind of makes sense when we look at something simple like that. But it wouldn't really matter what you had down here. It could be 50. And if I grew by another 10 points out of 50, I could think of, well, how would I convert that to being out of 100? So I believe that this is just the same as 20%. So I can figure out percent increases by taking how much something changes compared to the total, which I already wrote. I don't know why I'm writing that again. So we'll see how this goes. So looking at the examples that they give us, first of all, they want us to be a little bit thoughtful about this. So state whether each percent of change is a percent of increase or a percent of decrease. That's kind of just a catch to make sure that you don't rush through these and find yourself making a careless error in the final answer. And although it might be a little bit silly, if these were word problems, we would probably pull out what the original is, so we could rewrite that. So I'm going to find out if the new is smaller than the original, then that's going to have to be a percent decrease. So we're just saying what it is. And then next it tells us that we have to find out what the percent of change is. And the way that we'll do these, we'll figure out, well, how much did it change to begin with? So humor me by writing this for these early ones. Well, it was 30. Now it's 28. And no matter what, it's good to just subtract those numbers from whichever one's biggest. Don't worry about whether it be negative or anything, just find the difference. So it changed by 2. Well, if it changed by 2, that means that I'm going to take the change and divide it by, or set up a fraction really, over what it originally was. So it grew, or it decreased by 2 compared to the 30 that was. And then to find out what this is, we want to deal with this number out of 100. So here's the number 2 out of 30. And we want that to be the same as a percentage. And all percentages that we're used to dealing with are out of 100. So that means I will solve for some variable. Now instead of writing x like I often do, you can do that anyway. R is what they commonly use because it's like a rate. So then we'll do the whole cross multiply thing. So I'm going to take R times 30. And that's going to be 2 times 100. And sometimes it's nice to avoid multiplying these out. And the reason it's sometimes nice to do that is because then when I go in and I divide, to solve that problem, these numbers often cancel out nicely. So, the 0 would go away. And then I could have 20 over 3, which doesn't simplify nicely. And since we're talking about a percent of problem, you're going to hear me typing because I'm going to do 20 divided by 3, and I'm going to get 6.66666 repeating, and I'll round that to the hundredths place. If they said to round to the tenths place ever, you just round it to 6.7. always a good idea to see if you think that's reasonable. Well, that's less than 10% in decreasing it. And if I'm pretty quick with my numbers, then I know that 10% of 30 is 3. And since this number is smaller than 3, I'm going to agree that this number of 6.67 seems pretty darn reasonable. Okay, now kind of speaking of the same idea there, if it was 30 and it's now 12, to me that sounds like kind of a dramatic increase. And half of 30 would be 15. So early on, maybe I put a little thought off to the side and I think to myself, it's probably got to be bigger than 50%. So I'm going to put about 50, but it's going to be bigger. So no change on how we approach this problem. But we do know that it's going to be a percent decrease. So first of all, we will state that. So here's percent decrease. And as we set this up, 30 minus 12, we'll show our work for that. It's going to give us 18. And that means that the amount changed, 18, has to be compared to what it originally was. And so you look at it and you're like, well, was it 30 or 12? Well, I slow myself down just a little bit and make sure that I don't write 12, but instead write 30. Because you change it based on what it used to be. That would indicate growth or loss or whatever. All of the fractions that we're used to dealing with can turn nice to percents. And again, we use r rather than x or something else just because it suggests the idea of a rate of change. Cross multiply, giving us 18r, giving us 30r equals 18 times 100. And again, you could write 1800, that's fine. But as we go and we solve this algebraically, there's times where this really cancels out nicely. So this one doesn't too much, but the zeros go away. And then 18 is 6 times bigger than 3. And then that means that I never had to pull the calculator out to figure out that 6 times 10 is 60. Which means that we have a 60% decrease. We didn't write decrease in the one above. Go back and sneak that up there. Let me fix the spelling on that. I just was writing too quick. Cool. And because I did a lot of the thinking ahead about this, we've already sort of talked about the check, and it does match up with my guess. So I'll just revisit it quickly. If it was 30, it's 12 now. To me, 60% seems like a reasonable answer. Okay, we'll make this one an OYO. I will put the answer up in 5 seconds. Okay, so here we go. Not too much to talk about. Here, it turns out that I got like 6 over 11. I mean, nothing really went further than that, so did have to go to the calculator for that one, and I rounded to the nearest hundredth. So 55% roughly is what I got. And if I look at the original, it was 66. The new's 30. So half would be 33. So it's a little bit more than half that got knocked off, so this makes sense to me. Okay, now the only thing that makes this one any different is that you have now a new that is larger than the original. So we can go ahead and quickly do this one together, I guess. So we're going to have a percent increase. And over here, since I got the room, I'm going to do 12.1 minus 9.8. And if you're handed decimals, we'll stay with decimals. So here's 2.3. So the total change was 2.3. It decreased by 2.3, but I don't bother with negatives or anything, and nor will your textbook, and usually it just keeps it simple anyway. Now you have to make sure you compare that to 9.8, because that was the original. So the original was 9.8. And once we set this up, we're going to have the r there and 100 down here. And we're going to cross multiply. And notice that I haven't been bothering with showing this. It kind of becomes a accepted thing at this point. So here's 9.8r equals 2.3 times 100. So maybe you change that now, maybe you change it later, whatever. That 3 looks kind of poor. Solve it by dividing by 9.8. And nothing about this makes it different since it has decimals. It's the same type of process. And so you hear me typing 2.3 times 100 divided by 9.8, and I'm getting 23.5%. And this is a increase. So that means it went up by 23.5, which means it's 123.5 of the total, if you wanted to think about it that way. When I look at this, pretend that's 10, pretend that's 12. So it seems like from going from 10 to 12, well, that would be a 20% increase. I'm just looking at that and figuring it out. And this is a little bit more than 20%, so my answer seems reasonable. We will hang tight on word problems for this second video. So hopefully everything in this one felt pretty comfortable as we start to look at percent of change, where we have to use ratios and do cross multiplying, then dividing to solve.